Thanks for the opportunity. One thing that I just want to say up front is that I didn't get the same quality of talking around the challenges that we've got, that Prof. van Niekerk has got. So sometimes I will step on toes. I don't know who is in the discussion, and please excuse my frankness if I step on some toes around the challenges that we see in South Africa. So load shedding and power cuts, what is really going on? I've just got a few slides because I wanted to keep it short and to the point. This slide, and I haven't seen all the presentations before me. You probably have seen this. This is Eskom data adapted by Chris Yelland, and that shows the electricity availability factor from 2016 to date. And you can see what's happening. The EAF is going down and down and down. For anybody that has worked in industry and that has maintained plant in their lives, they will know that there's a point where you've neglected plant so far that you actually can't recover from there, and it's challenging. And I think that's one of the biggest impacts on load shedding is the fact that we're operating with this old plant. Here you can see more than half of the power stations are over 37 years old. I'm sure Jared Wright also alluded to that. Jared, also slides from you. You've probably shown it. I haven't seen it, but what's interesting here is that the planned outages versus the unplanned outages from 2017 to 2021, and you can see that progressing, is that the amount of unplanned outages is increasing dramatically, and you can see that moving to the right over time, and that just shows you this the reliability of the plant is low, and therefore it doesn't matter what you do to improve it, you just don't know when it's going to break down. So you can't plan for maintenance anymore because it catches you out all the time. Let me step back and just talk about technology disruption, because I think that's what caught up with us. It's a combination of technology disruption and overregulation, or should I say, the incumbents trying to protect their turf. So technology normally develops around an S-curve like this, and the first part of that development is normally exponential, and that has happened over time. Prof. van Niekerk also referred to that. You can see solar costs coming down in the last 10 years 20 times, wind costs coming down 3 times, and battery costs coming down 45 times. So that downtrend in cost from renewables is driving the technology disruption that we're seeing. So let's look at this causal feedback loops from Rethink X and the SIBA technology disruption framework. So you get new technology. What happens is costs are getting lower and lower, and let's just talk about renewables. I've shown you in the previous slide, 10 times, 3 times, and 45 times cheaper in the last 10 years. And as you've seen in Prof. van Niekerk's slides, coal has not become cheaper, nuclear has become more expensive, and I didn't see carbon capture and storage on there, but definitely not cheaper. So new technology, lower costs in the renewable sector is driving more demand. More demand is driving more production investment, which is driving more supply, which in turn drives lower costs. And that we've seen dramatically in South Africa in the last 10 years. So if you've got lower costs, then there's more infrastructure investment and more government support. We've seen that in IRP 2010, where government forced the renewable into the mix, and where there was investment in the IPP office and in running the REAP programs very successfully. So what that turn drives then is again lower costs, better capability, more public acceptance, and then stronger network effects. And stronger network effects is simply that every time you go around this loop, this causal feedback loop, there's a bigger impact, and that drives that exponential lowering of cost and then uptake of the technology. But that also then drives less demand of older technology. So what do we see? Is we see less revenue. We see less supply. And then from that less supply, sorry, just get the right. You see less supply, less revenue. That drives again less demand. You get your higher costs and less profit, less production investment, less infrastructure investment, less government support, and then less public acceptance and weaker network effects. And this is happening all the time, and it's happened in the last 10 years in South Africa around variable renewable energy, but there was a difference, and we'll get to that soon. So technology disruption, as you know, there are three examples here, from the horse carriage to the vehicle, from the normal camera to digital camera, and more recently, the old blockbuster video versus Netflix type of change. It's all dramatic disruptions from technology, and it happens quite fast. Of course, what we are talking about today is variable renewable energy and the impact that it has in terms of technology disruption on the whole fossil fuel industry and the supply of energy through that industry. Now, where I'm going to tread on some toes is what has happened in South Africa is that we've gone through technology disruption, but with the backing of a schizophrenic government, and the causal feedback loops then does something else. You've seen that new technology, lower costs, more demand, drives more production investment, drives more supply, goes to lower cost, again, more demand, more infrastructure investment, more government support, better capability, more public acceptance, and the stronger network effects. And this happens all the way from May 2011. Well, let's start earlier. Let's say with the white paper in 1998. Later with the adapted ERA, the Electricity Regulation Act, as well as IRP 2010, the creation of the IPP office, as well as then the world-class REAP program that really drove everything until it came to an abrupt halt around 2014. So what happened? Less demand, old technology, less revenue, less supply, higher costs, and everything else. Less production investment, less infrastructure investment, and less government support. So, and that's why coal-fired power is not becoming cheaper. Nuclear is not becoming cheaper. Carbon capture and storage is not becoming cheaper. And the myth of clean coal technologies, you will never see clean coal technologies going cheaper at this stage. I don't think that it actually exists. But what did our government do? They actually did the following. So they, during 2014, they started seeing, okay, we've got this problem around our fossil fuel industry. Let's give it some more government support, not less. We forced it in. How did they force it in? There was state capture. Eskom, as a government-owned or a state-owned entity, in a way didn't become state-owned anymore. Mr. Gigaba entered, Minister Brown entered, and the shots were called by the Gupta family. So Eskom was actually a bit Gupta-owned, not state-owned. And Mr. Molefe and Koko decided not to sign PPAs in the REAP, and the REAP started to fall over. So what happened? That was actually less government support, not more in new technology. What happened? The network effects halted. Supply halted. And that led to where we were, where there's an IRP 2019 where there's still coal in it, although it doesn't make any sense, where our incumbent minister is still driving clean coal, nuclear, gas, and all of those other technologies that we've seen in Prof. Van Niekerk's slides. Has it not become cheaper? In some cases more expensive, while we don't have the government support for renewables in the country. It's been a stop and start, and because of the network effects that halted, the supply actually halted. So you've got less infrastructure investment and the challenge that comes with that. So just typical obstacles to resolve load shedding. We've seen it. This is from the RSA Energy WhatsApp group that I'm part of. And over the weekend with the load shedding, one of the people on the group said, any ideas how I could sell my excess electricity to a specific grid connected user? The specific person has a PV plant with battery storage, and he was oversupplying himself, and he could supply somebody else. And somebody else on the group just said, you can't. And that's the fact. The fact is there are probably gigawatts of solar PV constructed on rooftops and embedded generation facilities in the last few years in South Africa, but nobody of that can trade with that excess energy. They can just use it themselves or curtail it in their own systems. So if we then go on and we look again at this technology disruption in the clean energy U-curve, and I think that this is shown in our RP, is that you need anywhere between 3 and 5 times your current generation capacity if you go variable renewable. So if you've got, let's say, 40 gigawatts of installed capacity at this stage, you need 120 gigawatts more or less to 160 gigawatts of renewables, and between 35 and 90 hours worth of battery energy storage, and you can actually go to a complete renewable and battery storage system. So let's apply our minds about the solution. I've just shown you more or less an optimal system. IRP 2019 was a very good start to create a pathway for this. IRP 2019 needs to be updated with new data across, especially in terms of battery storage. Investment in grid infrastructure needs to be prioritized. The government needs to show commitment to push through with the unbundling of Eskom, support renewable energy and IPPs through the REAP, but also through enabling private power purchase agreements between IPPs and private off-takers. The 100 megawatt cap for a generation license is absolutely a step in the right direction, but NERSA should optimize its processes for registration and licenses, and NERSA and the municipality should allow excess energy from CNI installations to be fed back into the grid. And that is my presentation.